thank you for coming along this morning. It was a bit of a struggle to get out of bed this morning, but yeah, pretty impressed with the turnout, so thank you. Briefly, we're going through some of our favourite use cases for SPL and some of our favourite things that we've learnt through our experience with Splunk. Very briefly, my name's Chris. I work for FIS. As Matt described yesterday, probably one of the biggest companies that nobody's ever heard of. We're the world's largest fintech, and I look after the development of the cards-based platforms for international. So I look after credit card processing, loans, API gateways, browser front ends, and so on. We started our Splunk journey probably 3 or 4 years ago, very much out of necessity. And we were drinking from the fire hose, learning very quickly. I wasn't smart enough to go and do the Splunk university training. Looking back, that would have been a really good idea. I found that learning through Google was a lot better. So there's probably a lot of stuff that I learnt from a number of people in here that have either put questions or answers out there on Answer. So thank you. I really appreciate your help. That's me. That's the best stock photo I could find of myself. I don't do many selfies. There was a fancy dress party for a mate of mine's wedding anniversary. I'm up here with a good mate of mine, Matt Moore from Splunk. We put together this session. Matt said, that's one of my favourite topics. I'd love to come and chat. So we decided we'd do it together. So, Matt, thank you for joining us.
Thanks, Chris.
Okay. Forward-looking statement, if you want to catch a micro nap, just so that you can get ready for the presentation. Put it up there for a second. I don't think that we'll be doing any forward-looking statements. Okay. As I said, we brought on and started using Splunk very much out of necessity. We had to get it in and operational very, very quickly to meet some operational requirements. But we did a lot of work through cut and paste and learning on the fly and playing with it. I was using an older version that didn't have the syntax highlighting, that didn't have the nice auto formatting. When they came in, it was like, oh, this is so much easier. But anyway, we've now got a fairly extensive library of things that we do, a lot of tricks that we learnt along the way. Hopefully, you'll pick up 1 or 2 that you might take back and use in your organisations or your personal use. There will be a lot of SPL, so I'm not going to apologise for that. I put it in the title of the presentation so you know what you're getting. But don't feel you have to remember or write anything down. We've got this as PowerPoint right now, but we're actually going to be flipping across to a demo. Okay? The demo is actually a Splunk app. So most of the sessions that I've gone to that I've enjoyed the most is where people are presenting on an app doing a live demo, and you learn not just what they're teaching you, some of the other things that you can do in the platform just for the way that they've done things. So I've done that a number of times with sessions, so I want to do the same again here. The app is available for download, okay? So we've put it up on GitHub. The link is right at the end, so don't feel you have to write anything down. We're going to show you the SPL, but really going to be talking more concepts rather than walking you through line by line the SPL. Okay? Handing over to you, Matt.
G'day, guys. Looking around the room, I wouldn't be surprised if the vast majority of you have at least played around with SPL, if not spent nights upon nights playing around with it, trying to get things to work just the way you want. And one of the things I love about Splunk, and I'm sure you do too, is you've got the luxury of having about 5 million different ways of doing just about anything that you're trying to achieve. Some of them work better than others, some of them can be more effort than others, some of them are really quick and easy to get up and running. But the take home is there's a lot of different ways to achieve what you're after. Now, some of these particular ways of skinning the cat are quick and easy. Some of them are a little bit stickier than others. Some of them can result in bits of cat all over the room. And I think I'm going to stop using that analogy at that point. We're going to take you through some of our examples that we've come through our own trials and tribulations, and actually show you some of the SPL that we've used in real-world scenarios, but against obviously different data sources rather than the ones we were using them against. So you'll be able to take this app, download it, borrow the SPL, tweak it to your own needs, and make it yours. The only ask I have of you when you do come to download the app, please don't come back and criticize my horrible, horrible JavaScript. It's an SPL app. The JavaScript is...
To make it look pretty.
Yes. And back to Chris.
Okay. So we've tried to break things up into categories, a couple per category. Main ones, improving your formatting, wrangling your data. There's a lot of places where your data is going to come through in a format that's unusable. We've got some great examples where we've got some just horrible data that's bordering unusable. Trying to get back to that host system to change that data is, again, going to be impossible, but we've got some tricks on how to do that just with SPL on the fly. A lot of summarization and real-time data. I'll get into this in more detail about combining searches together. Adding smarts to your alerts. I'm sure I'm not the only one. When a system goes down, you've got your database goes down, and then you get alerts at your full technology stack all the way up. And that's not really useful if you know the problem is right at the end point. So being able to automatically suppress those alerts at higher systems when you can see that there's a problem further down. So trying to stop that alert storm. And finally, speeding up your searches. So some tricks that we've learned along the way about things that work very well in Splunk, and some things that you are there but you really should avoid unless it's a fairly limited use case. Okay, so improving your formatting. So again, there's some great commands in there. One that I'm a big fan of, and I think most people use, time chart. Fantastic if you want to see what things look like over time to present on a dashboard, but it does have some limitations. So for example, you can only do a single summary by, and one aggregate by. If you use the stats, you can use as many by aggregations as you like. Okay? Hidden fields. A number of times I've gone out there and gone, really there should be a Splunk field for that. And oh yeah, there it is, it's hidden, I just couldn't find it. So using transpose to find that. A lot of the add-ons that you do into Splunk only allow you to use tokens. So if you're linking out to Opsgenie, you're linking out to Jira, then you can only put in a single token, and you might want to get a whole table of data. So being able to take a whole table of data and putting it into a single field. Okay. Wrangling awkward data, I'm going to hand that one over to Matt. Matt found the most complicated example and he walked me through it, and my eyes glazed over a little bit. Yeah, took the most complicated example he could find and managed to wrangle that data with SPL. Bring summary data up to date. So summary data, typically you're summarizing every day or every hour, every 5 minutes. You might want to look at raw data to bring it up to date. So I'll show you how we've done that. Okay. Your alerts. You've probably all seen this. A lot of organizations go, I want to go put an alert out, and there's an alert, and then another alert, and now there's 5 real-time alerts. They're all doing very similar things. What we've done to effectively condense all those into a single alert and trigger those off. Okay. Suppressing alerts, which I talked about before. Okay. And then some of our tricks around how to speed up those searches, and what we've done to avoid the very high CPU use SPL commands. Okay, we're going to flick over to the demo. The slide deck is there, and so it's got the details in it. But press that. There we go. From now, we're going to run things out of the app now instead. Okay. So the first one, that's going to bring up for us. Okay. Talking about the bin, stat, and time chart. When would you use a time chart, and when would you want to use a stats command instead to get details by time? The thing about time chart is that it's context aware. Okay? It knows and fills up, gives you the whole time range, and then goes and puts the data into those time ranges. So if there's no data for a time range, you get blanks in your view. So therefore, when you graph it, you'll say here's an event, and then there's nothing, and then here's an event. If you do a stats instead, then it won't fill up that table. So you will then get these basically no gaps. Okay? So if you're charting it and you're putting on a dashboard, you want to use a time chart because it gives you that context. But if you're downloading and you're putting into an external source, or you want to get a list of all the errors for a particular week, you don't want to see the full week's worth of details. You only want to see the errors. You can summarize those up. Okay? So we've used this a lot on when we're pulling out, here is a list of all of the incidents that we've had. We don't want that time chart. We want the table of just the errors. But also, as I said earlier, you can't do that group by. So under the time chart, you've only got one group by, but the stats command, you can group by as many things as you want. I want it grouped by server. Well, actually, I want it grouped by server and client and by country. Okay. Secondly, also talking about those hidden fields. So trying to get in and see those hidden fields easily, so you can see what those values are. We've been using use the table. If you use that table command, you're going to get anything that's got an underscore is automatically removed from the table. But if you do a transpose, you actually get those formatted nicely. So I hand over to you, Matt.
Alrighty. Let's just scroll down a bit. So just to highlight the first point there, hopefully that text isn't too small. Let's make it a bit bigger. So using time chart, I mean, we're all familiar with time charts, one of the first things you start using. The whole raison d'etre behind it is it handles time series data natively. So it understands that if there is a gap between two values, it doesn't necessarily mean the two values are neighboring. It just means there's nothing happening there. So you can see when you put that in a line chart or area chart, handles it beautifully, really easily. Whereas if I tried to do the same thing using bin and then chart, or bin and then stats, then it has a jolly good crack at it, but neighboring data fields are in fact plotted right next to each other. So clearly, if you're working with time series data, time chart's always going to be your go-to. However, as Chris mentioned, the advantage with using bin is then you can run more detailed analysis over time series data or any other type of data if you're binning on things apart from time, and then using things like stats and chart with multiple group by clauses. So in this case, we're looking at the internal index, and we're binning everything into 30-minute intervals. We're able to start working out the count by the time of the bin itself, as well as the action and user, and you can pile on as many as you like there. Comes in very handy for putting together alerts and for checking SLAs, and you've got a lot of group by potential to check multiple things simultaneously. Just doesn't look quite as nice graphically.
Nah.
Now to come back to transpose, now this is really interesting because I had no idea about this until Chris brought it up with me. So as you probably know, there's a ton of hidden fields in Splunk. Events will have things showing you the index time, what bucket they come from, all sorts of really handy stuff. However, if you start looking inside the events themselves, hidden fields apart from time, which isn't technically hidden, don't generally turn up. And if we look at the same thing in a nice horizontal table using table, if we scroll through it, you will eventually see that there's some fields starting with an underscore there, so, or at least some point. However, it's not the nicest thing to go through. However, as soon as I add transpose, effectively what that does is turn your entire table or your entire raw data set on its side, and it gives you this beautifully formatted vertical list of the fields that you're after, including all of the internal fields for the particular data set you've got. So a very quick, easy way to find out what hidden internal fields are going to be available to you, so you can use it for validating your data or within your queries. And hand back to Chris.
Yep. So that transpose, I found we were running at FIS, I agreed to SLAs around how quickly data would be indexed from the time that the event created until the time it was available to be searched. So I needed to be able to run some statistics of what was the time of the event and what time did it get indexed and how far off was I. So if it was more than 2 seconds or 3 seconds, I was going to be failing my SLA. So I needed to go find this, but what was nice about the transpose, I didn't just go out and get the field by seeing it in that table. I could see here is the field name and here is the value. Allowed me to write my SPL a little quicker. Formatting. This one, again, built out of necessity. We've put in, as a part of our alerts, to go and raise Jira tickets straight out of Splunk. But that add-on for the what to do when you trigger the alert to link into Jira, you could only use tokens, and the token only looked at the first row in your table. So if you created an alert, you created 5 alerts with a single stream, you only got access to row number 1 in that. Okay? But I didn't want row number 1, I wanted the 5 alerts in order with the headings in my Jira, just like you would get if you were saying, send me an email with the table of the alerts. Okay? So went through and worked out a way, how do I get all of that data into the first row formatted in a table format in a single field so I could use it as a single token. Okay? That then stuffed up my emails. My emails then didn't have the nicely formatted HTML table in it, so I took one step further and made it a hidden field, so that way the email went out with the alert, nicely formatted HTML table, and my Jira alert, again, got a nicely formatted text box.
Right, let's have a look at what that looks like. So just to scroll down a little bit. So right now we're looking at what the original search results look like. In this case, again, using our internal logs, but obviously very different data out at FIS, giving us a table of results. In this case, the host, which is my laptop here, the user, and what URI path has been pulled in. Now, slightly hypothetically, because this is not the data you'd use for that situation, but say we wanted to turn that into a Jira ticket. Very easy to have that as an alert that fires off as an email and include the table in there. But if I want to use a Jira plugin or a ServiceNow Remedy plugin, what have you, I'm going to need to pass all of that through in a single field in order to format it nicely. So we can make use of a few commands to make that a little bit easier, accelerate that process a bit. So we're going to use Streamstats first up, which in this case, I'm just going to use very simple Streamstats count to add some line numbers. So that we're able to determine whether this is the first line or second or third and so on and so forth. Reason we're doing that is because for the first line, when we actually start putting this together as a table, we're going to want to include our table headers. So your first line, as you start to put this together, is going to look different from subsequent ones. Then using eval, and we did say there was going to be a bit of SPL in here, we're going to start putting together what each line of the table is going to finally look at, using pipes as placeholders for our line breaks when we put them in. So what you can see we're doing here is checking if it's the first line. So if row count equals 1, it's the first line. And if that's the case, we're going to insert a series of strings that are our column headers. So host, user, URL path, and so on and so forth. If it's not, then what we're doing is putting the individual values of the fields in our original table in there, padding them out with text strings, which I'm using as basically a substring of a row of spaces minus the length of each individual string, just so I can get the column width exactly the same. Just makes it look a little bit prettier. Looks a little bit like the dog's breakfast, but when you put that into your own SPL window, it's a lot easier to work with. Now, finally, we can use event stats to bring all of those alert text values into a single field. Now, you can see here in the jobs result field that we're putting together, they're all identical, and they're all basically a combination of every row within our original table. And this is where it gets a little bit cool. So, with the rex command in sed mode, we can do find and replace, but actually use /n for your new line character. So we can go and pick up anywhere it's got the pipe in there, replace it with new line, and Robert's your mother's brother. We've got job results as an actual table with line breaks rather than pipes at the end of it. And if I just grab a single one of those, you can see at the end, this is what's going to finally get sent to Jira or whatever ticketing system you have, or any other application that's you'd like to send a table to. So fairly quick and easy, and certainly something you can cut and paste when you download the app rather than go through your own trials and tribulations. Now, interestingly, the last thing that Chris said was being able to use that for both an email and a way of sending a ticket through to Jira. Because of course you can have different alert actions or multiple alert actions on an alert. Now, by setting this to a hidden field, so underscore job results rather than job results we used there, your traditional table within an email will actually not include those underscore fields, so they get excluded automatically. However, we can use transpose here to bring it up. You can still access it as part of your alert actions. So you can still put in $_ job results $ and send it through to the alert action of your choice.
Okay. Next one was a situation that we found. The data that we were pushing into Splunk was effectively pushing it through with header 1 that had 3 fields, header 2 that had another 5 fields, header 3 had 4 more fields. And then the data record came through with 2 or 3 fields, but I needed the data from all the ones above it as well, so I could process them all as a single event. But the order of the events came through not as always expected, and it was very difficult to try and get all of those data elements from all of the header records and then the detail record all on a single row, so I could then process and run my stats commands. Okay? But again, using a combination of Streamstats, I think most people are already aware. So you get your add totals to put things at the bottom of the table. You've got your Streamstats, which is process each of the events with history up until that point. And event stats says, go get my full history and go put it on each of my individual rows. Okay? So using a combination of Streamstats and event stats, we're able to get all of those fields all onto a single event record to then be able to do our subsequent processing.
All right, now this is where it gets a little bit fun. So rather than use some of the data sources that we come across every day, I decided to be a little bit masochistic on this one. So there's a couple of data sources in particular that actually look reasonably easy to understand when you first look at them, but when you work with them, a little bit less so. One was parking data that was picked up by a local council back in Melbourne. It was interesting in that for a particular series of events with one timestamp, you could either have multiple cars entering and leaving the place, or you could have one car staying for long periods of time and have that come through as multiple batches. So as you can appreciate, you need to work out what the event boundaries are, whether someone's come and gone, whether someone's been there the whole time, and compare disparate events separated by other random garbage. The other one, which is what I'm going to show you today, was something I encountered tracking flight data using GX KML files. Now, the interesting challenge there is, while it's actually a fairly simple looking piece of data, and we'll scroll down and have a look at it, where you've got a particular asset name, which might be an aircraft or a boat, or I just put car in this one because I didn't want to share the data that I was actually working with, and then a series of times and positions. Now, the interesting thing is, for each track and each vehicle, the number of times and positions, while they match each other, will actually be different. So the offset changes every time you get a new entity within this file. So here we've got a car with a series of GMT time coordinates. And as I scroll through, we've got other things turning up with other numbers of time coordinates as well. So the trick there is being able to recognize the boundaries and cascading asset names through it. So I'll just show you what that looks like. So again, Streamstats, useful for a lot of things, but even just being able to put line numbers in is incredibly useful when you're trying to work out the distance between disparate events. Then, in order to make sure we've actually got an asset label or an asset field within every event, so you can see the asset for car has been labeled here, but it then stops existing. Make use of fill down, which is surprisingly useful for something that everyone's used from Excel since back in the day. But what this will do is basically fill down that field until it encounters something that isn't null. And so it just allows you to persist things downwards. It's really good for time series charts when you've got an event, a switch turning on or an interface flapping, and you want to carry that status until it changes again as well. So now we've got the line numbers identified, we've got the asset name identified, and that's where we're going to start looking at boundaries, where it goes from a time type data to a latitude and longitude type data. or something else. So using Streamstats again. Now with Streamstats, you can either have an ongoing count like we do with line numbers. It'll just keep going from beginning to end and update the latest value of a field or the sum of something or the count of something. Or you can specify a window. In this case, with a window of 1, counterintuitively, it actually compares 2 neighboring events. And because we're using current equals false, it's actually the previous event it's comparing. So what we're doing here is using Streamstats to find the last time value and the last latitude value, then using eval to work out if there's no time value but there's a latitude value, then it's this type of boundary, and if vice versa, then it's that type of boundary. So we can actually start putting together these boundary events. And the reason we do that is so that we can then go and use event stats and work out from the line numbers of the 2 corresponding boundaries for that asset how far apart their relevant data sets are. So what that allows us to do is work out the offset and then create a field called joiner. I wasn't feeling very creative at that point. So what we do then is basically make sure that for each line within the time series data and each line in the geographical data, we got the same value for that field. And we're able to use stats to bring it all together by the asset name and the joiner field we've got. And finally, we've gone from reasonably unpleasant to use data to something that's just a standard table. Time series data with latitude and longitude. Searches actually run through relatively quickly. You wouldn't expect it with the number of Streamstats and event stats commands, but it's actually quite performant. But even if it's not, and you've got this data coming in on a regular basis, using summary indexes is fantastic for that.
Okay, next one. So we went from a very low volume of data. All of my dashboards were all looking at just the raw data in the standard index. But as the volume of data that I was processing got larger, those dashboards started not performing very well, and all of my reports started not performing very well. So then went and moved across to summary indexes. Very, very easy. You take your normal stats command and you put SI in front of it, writes all of those metrics out quite happily to a new index called summary, and now I'll go pick it up from there instead. Problem is, now my dashboards are only looking at summary data, and you can't see up to the minute or up to the second what's actually happening in your system. So then I need to have 2 dashboards. Here is the dashboard that's looking at raw data. If you want to see up to the second, we've got an outage. When's it coming back up online? And then you have to have a second dashboard for my summary data. If you want to go look at last month or the last 3 months of data, you then have to look at a second dashboard. I didn't want to have to train everybody in my organisation. This is when you use the raw data dashboard, and this is when you use the summary index dashboard. So we went through and worked a way to combine the 2 together. Okay? So as you're doing your time selection, your time period selection, that drives into your search. But you can override your earliest and latest actually in your search. So using SPL, saying go get everything from the summary index that's available for that time period, but wherever the last event was, get from the last event on the summary index through to the end of the time zone and fill that up with data from the raw. That way, I'm summarising data every 5 minutes. Somebody can search over 3 months and get almost exactly 3 months worth of summarised data, and then 5 minutes of summary data, and build up that nice search to give you your full time period up to the second, and you've got both real-time and summary data in a single dashboard. Have you met?
Okay, let's have a look at some of these searches. All right, so to start with, just to highlight a few other points, I'm going to start with a search period of just over 60 minutes, and we'll start with the summarized data to see how that will look. Now, I've actually got a summary search running every 15 minutes on this laptop across our internal data. So when I start looking at certain aggregated fields I've put together, now they're very arbitrary in this case. I've put together some rather fake SLAs to use against your internal data, and they'll run the same on your laptops, and pushed it out into the summary index. Now you can see here it's a very fast search. It's only over 60 minutes of data, but that scales very well. So if I ran it over 24 hours or 7 days, still a relatively quick search. But the obvious disadvantage here is it flatlines at the interval at which it last ran. So of course, if you've got that powering your dashboards, it's not going to be up-to-date data. It'll be lightning fast, but there's going to be an inherent delay in there unless you happen to open it just after the summary search runs. Now the other option is, and again it's a bit of a no-brainer, we could just run the search that powers the summary data in the first place. So just search across the index data by itself. Now obviously that gives you completely up-to-date data, and is relatively easy to achieve at the expense of time. Now, as I start to pump more and more data into this, the difference between the two search times becomes significantly greater. Now, what Chris was just describing was a way of combining these two searches in a way that uses the summary search for the length of time the summary index actually has data, and then working out the cutoff point and then running the index search at that cutoff point. Now, I apologize for what this looks like. It's a bit of a, in this particular window, it looks a little bit like the dog's breakfast. There's a fair bit of search there, but I'm going to break that out into the search window so we can start pulling that apart, because there's a couple of parts of the search anatomy that are actually quite interesting. Actually, before I go, this is the point where it gets really peculiar. This search actually runs slower over the 60-minute interval. Now, I'm going to leave that with you for a second. We'll come back and see why. And how we can take that into account as well. But to break this out into standard search window and take advantage of some of the formatting, I'll just take you through what the anatomy of this is at a high level, and I would encourage you to download this and go through this one. So starting with our summary search, we're just running through summary data, pulling out the information as best we can, and then running an append command, where we're going to look through the summary data again as a sub-search, looking for the most recent event within the summary data, so head 1. Now within your summary, and I don't know if anyone's actually broken apart or run a summary search and not aggregated it. Within each of the lines contained within your summary index, there's an info max time and an info min time, which is the time range of the search that generated the summaries. So for the most recent event within your summary search, you can see what the time range was and work out what the earliest time and what the latest time within your summary data actually is. So by using that, we can run we can use eval to whack info max time into summary max time, and then add info to find the time range of the current search. So using that, we can go through, evaluate what the earliest is. If there's an earliest time within the summary data, we go ahead and use that. If there isn't one, we go ahead and use the time range of the overall search. So basically, if there's no summary, just run index search for all of it. Pass that back to the index search that we're running here. So index equals underscore star, pass earliest and latest back, and then append the two data groups together and use a further time chart to sum up the values from both. And you've got data from both your summary and your index data completely up to date and still reasonably performant. Now, I say reasonably performant, even though the search I just ran was actually slower than the original one. Now, that's because there's a little bit of heavy lifting to get it up and running. You can see there's a few extra commands in there. We're doing some evals. We're playing around with the data a little bit. When we increase the time interval, it starts to get more and more beneficial to do it that way, because the heavy lifting and the index time data actually makes less and less of the search time. So here you can see over 24 hours, it's significantly more performant than just running across the index data, and has up-to-date information as opposed to summary data there. And as you increase that interval, you're increasing the flexibility of the dashboard, but also vastly improving your performance.
Okay, that one's one of my favourites. So it made a lot easier. People were running these long searches. Can you just not search over 6 months, please? Don't only use a month. Now it doesn't matter. The searches are always nice and efficient. Next one, really this was me stopping our alert storm. Okay? I've got 5 levels in my technology stack. I've got all of the same data, all of the data from all of those stacks in my, all those platforms in my stack, and I can see when one of them's down. So therefore, don't alert at the top of the stack if the one at the bottom of the stack is out. Okay? So if my database is offline, don't alert on my API gateway giving invalid responses. Okay? So Using this, doing your standard alert calculations. Going and using the stats command to go and get, how long have I been down for? I've been down more than 5 minutes. That's an outage threshold. And then adding in a join to go and look for what's happening in my downstream systems. And if they're down or up, just setting an indicator and working out whether or not we should suppress those. Okay? The other thing we've got here is you don't have to go and create separate alerts for every one of your systems. Okay? So I've got host number 1, create an alert for an outage. Host number 2, go and create an alert for an outage. Host number 3, now you've got 3 separate alerts and they're all running on the same schedule, they're all doing the same work. But you can look at your, across your index and say, look at all of the index, one alert that runs across your 3 hosts. And by doing that, you can do your stats, which will do stats by host, and you can look at all 3 of them in one search. And now you're running 1 alert every minute rather than 3 alerts every minute. The same goes for if you're looking for historical. Let's say you're doing an end of day, you've done your alerts throughout the day, and the end of the day you want to say, go and have a look at all the alerts, all the outages that have happened through yesterday. You can then do the same thing. So you're using your stats when you're doing your alert, but when you're doing your end of day summary of the alerts, use the Streamstats. Go look for outages through the data, anywhere in the data, and you can do that again by host, by client, as many aggregations as you want, and then pull out that table. You've now done one search to look for 6 services in one hit, rather than 6 daisy-chained append searches. Alrighty.
So I'm going to start with combining searches into a single alert. It's been almost every site I've ever been to has started out with people writing a couple of one-off alerts, looking at a particular type of data, a particular entity, a particular type of incident. And then when you need to create another alert, you go and create another search, and all of a sudden you've got a ton of scheduled searches in your machine. Now, it's probably going to seem like a bit of a no-brainer, but even just using a by clause in a stats or a Streamstats command, and I can't believe how much of my life I didn't realize you could actually use by in Streamstats, but it's an amazing way of putting that kind of logic across multiple hosts within an index, or multiple entities, or multiple URI paths you might have in your web server. So just to show how that might be done, again, I'm using the internal logs because we've all got those available to us and it's easy to share. I'm looking for dashboards that haven't been accessed for more than 10 minutes, so we can pretend that's an outage. So you go base search, just looking for anything that's got web access, and we've actually got a user and an app available in it. Now we're going to find periods of inactivity. So Streamstats, current equals false, so we're not going to look at the current event, so it's going to be historical. And we're looking for last underscore time. So until the current event we're looking at, what's the most recent time that particular app has, or that particular view within the app has been accessed? So using that and passing it through to an eval, we can work out historically and moving through a time window, how long an app has been dormant, or how long a page has been dormant, or how long a host has been failing to phone home. And then finally, we can apply a threshold. So I've actually put in an artificial threshold there of just 600 seconds, just arbitrarily. Now you could bring in something more intelligent, like perhaps a lookup table if you had multiple different SLAs for different things, but just went with eval in this case, and using a where clause can just filter out anything that is within SLA. And finally, we've got an alert result, which will only alert on things that I'm actually interested in hearing about, but again, across multiple different entities simultaneously. Now, to very quickly speak to Chris's point about suppressing alerts, there are many ways of doing this. If you're using IT Service Insights, for example, the event analytics is a beautiful way of taking care of alert storms. But if you have a simple case where someone might be doing maintenance on a server and you just want to suppress any alerts for that server, then there are ways you can do that as well. So again, using my internal logs, bringing up a series of errors. So I've got a few things running on this machine that are a little bit questionable, a lot of Python that needs a bit of tidying up. Run a base search, bring up the errors, but then run a sub search using append calls, which is just working out if someone's been shutting the machine down. Now, this could be a search in your case for outstanding tickets for that asset. It could be searches for all number of things. But in this case, I found in my top right column, someone has been shutting the machine down. I'm taking that to assume work's been done on the server. Now, once again, I'm going to use fill down to just go and apply that to every line within the table, and then I can filter based on the value of that suppressor field. If it's greater than 0, then I don't want an alert, because if someone's shutting it down, this to me is an invalid alert. Now, if you're using an alert search more like the earlier one that Chris was mentioning, rather than using append calls, use a join and join on the field you're splitting by. Then you can suppress them individually.
Okay, and I think we're up to the last one, by my count, unless I've miscounted. Speeding up your searches. There's a lot of very heavy CPU SPL commands. Main one, transaction. It's looking through and trying to pull in all of the events and total number of events and total duration, and that is a very CPU intensive transaction. If you don't actually need to know all of those events in between, number of events and so on, you can actually get a lot more. If you're just looking for start and end, you can use the stats instead, and it's a lot more friendly. So stats, event stats, and stream stats can do that work for you, unless you specifically need a number of events in a transaction. Okay. Whenever you're doing these, there's always a need for it, okay? You're always going to find a need to do a resort of your events or a reverse of your events. Heavy rex commands, you've seen us using them before, the seed command, the streaming editor, where I want to go and replace a pipe with a new line. Do as much filtering as you can before you start using those heavy CPU transactions. Okay, and it's a little counterintuitive, but when you're doing your base search, the more search items you put in your base search, the faster it's going to be. So if you're only looking for one field, I'm looking for host equals yes, you put 4 or 5 other search items, key items, it actually speeds up that search significantly, even though you're getting the same number of events. Okay? Lastly, as everybody's aware, when you're doing that base search, it automatically goes and load balances them across all of your indexes to pull back data. But as soon as you add in a join or a sub search or an append calls, that subsequent command is done only on a single core, and it's done before the rest of the search runs. So if at all costs avoid your joins and sub searches, and try whatever you can to get that into the base search, and you'll get a significant improvement in your search performance.
All right, so I'm going to very quickly go through some examples of that, as I believe we're coming up towards time. But just to highlight that point about transaction versus search, I'm going to kick this off now. And I'm running a transaction command over my search ID on this instance. Now, transaction, it's not slow, it's just doing a lot of work. It's aggregating events together, it's looking for starts with and ends with clauses. It's very, very flexible. However, in 90-something% of the time I've seen it used, it doesn't actually take advantage, or people aren't taking advantage of these features. So what you're essentially doing is using a lot of compute to do something you're not actually using. And what you end up with is searches that take a long time and resources being used up. So here I've done that transaction over the search ID. It's taken 31 seconds to run, and it's strung together a series of events, worked out my duration and event count. Now, to highlight that point, I'm going to run exactly the same search using stats instead of duration. And we've got our durations and instead of transaction, we've got our durations and event counts, but it's gone through in 7.8 seconds, so a lot faster. Now, interestingly, and I set myself a challenge to do this a little while ago, and I'm not sharing it today, but I'm happy to if people ping me by email. You can actually get the starts with and ends with functionality using stats with and Streamstats as well, and it's generally about twice as fast as using transactions, so it's good to know. The other thing that was mentioned was joins or event stats. Splunk is not SQL. Joins are not the best way of doing things. It can be very, very powerful, but there are limitations in sub-searches. There's a maximum of 10,000 events that's returned unless you adjust limits.conf. There's also a maximum time period for the search to run, and a little bit of heavy lifting in the back end. So if I run here a join query, join over user with a sub-search, goes through, gets me the data over about 20 seconds. But the thing about Splunk is it's actually natively built to work with data that's just heaped into a giant bucket. So we can actually use event stats to start pulling in together values from disparate events. Like we're doing here, pulling in the count as event count by the actions and users, so joining them together on that. Using the maximum event count, again by user, so bringing that event count back into anything with the same username in it. And then finally, joining it all together, so top action as top action by user. Now the reason we're using values there is if you use list, you're going to end up with 2 of each of them, as you can imagine. But by using values, I basically go and fetch that top action, stick it into each user event, and then you get the same results, but a hell of a lot faster. Now we've got 33 seconds to get through the rest of it. So, that's all right, we can do this. So very quickly, you can do a lot of formatting within Splunk by combining your evals, your time charts, Streamstats. You can use transpose to find hidden fields, and you can use some funky stream formatting in order to place an entire table into a field. Streamstats and event stats are your friends when wrangling data. Great way of looking for boundaries and types of data. And fill down is one of your best friends for actually making something persistent across time series data. We can do some creative things with your alerts to make one search generate alerts for multiple entities and hosts. And we can also suppress false alerts by running a sub-search and then either using a join or append calls and fill down. Transaction is only good if you're actually using the core features of transaction. Otherwise, stats is going to save you a lot of CPU time. And finally, making your searches specific, throwing a lot of keywords and phrases into them is a great way of speeding up your searches because we have to pull less data off the disk. And don't treat SPL like SQL. Joins are not necessarily your friends. I'm going to skip this slide purely because I think we realize that we both know and love these commands. Streamstats, event stats, fill down, transpose, and rex are definitely your friends and will definitely be in the slide deck when you download it. Now, if you've got your phones handy, grab a copy of that slide. That's the GitHub account. I've got the app on. Please download it. Please don't make fun of my JavaScript, but if you have a look in the static directory, there is a JavaScript for the syntax highlighting you've been seeing as well if you want to borrow that. And finally, only slightly over time, please take the time to rate this session. And if you see myself or Chris wandering around, please pull us aside if you have any questions, or if you want to buy us a beer.
Excellent. Appreciate your time.